How magnetic pressure will come into picture here. Like we had in electrostatics, no? Electric field density. Electric pressure. Similarly, here, magnetic charge, magnetic field density will come into picture. This is very important. We don't have any question till now in advance possibility of asking. So how the current is flowing? So what I do is I'll assume the pipe. This is a pipe, no? This is radius r. So how is the current everywhere on the, because on the surface current is flowing, no? See, I can directly write formula b square by 2 mu naught. From there I'll manage. But when you go for application problems, no, you should know how that force will act. I can link this with elasticity. Some stress will be there. Then due to that deformation, we can introduce many other mixed concepts. So therefore, I'm preferring the force method rather than directly writing formula. So here the current I is flowing, this current I. So now let me assume a strip. Here I'll assume a strip, that one. So I'll calculate force acting on the strip, force per unit area of the strip. That force per unit area will become the pressure, the electric pressure. Then what is the current? How is the current flowing throughout the surface? No. Let di be the current flowing in this elemental strip. Length of the strip, let it be dl, and let this be dx or dr, anything you can write it, this one. So it is what we assume the strip like this. Now I think if I can force per unit area here, if I can calculate, problem is solved. Okay, what is this particular? So you assume two symmetric elements here. This is like a current carrying sheet only, no? Long current carrying sheet. But sir, you are saying pipe. Then again, you are using word here, long current carrying sheet. What do you mean by long current carrying sheet? There won't be beginning and end, no? Long current carrying sheet. What do you mean by that? There is no beginning and end. Look at this pipe also. There is no beginning and end. Here, this surface. Though it's a finite, but there's no beginning and end, no? So therefore, it will also behave like a long current carrying sheet here. So if I assume elements, so I'm asking you to assume a elements here. So let me assume that element here. So how is the current here will be flowing? Current here will be into the plane. So how b bar this will produce this element? This element will produce b bar like this, and here b bar, and this element will produce b bar. This element. So like that, why the net field inside the pipe? Here, what is the resultant field inside the pipe? You check it. So go back to electrostatic. Will it be zero? If a current flows on a surface of pipe, what is the b bar inside the pipe? Will be zero. The field strength here will be zero. What about outside? Outside will be non-zero. how do you can say, I think it's like a two current carrying sheets. Now what about B bar? This is one, this you take it. So this will produce B bar, B bar. This will produce B bar and B bar, and B1 equal to B2. What about field inside here at this particular point? In between will be zero, no? What about field here? These two will get added up, no? So again, what is the our basic way of learning things? We do show like this, no? Superposition. So here I should show B2 and the B1 I should show here. Will I agree? This is what actually happens. What should be the field between the plates? Will be zero. Field external to plates, like here at this point, the field here will get added up. Okay, let's come for Ampere's circuit law. What is the field outside the pipe? What is the field outside the pipe? I think that diagram. Where that current is enclosed here. And I'll assume Ampere's circuit law, Amperean loop. Let it be like this. No, this is the, what is the total current enclosed is I. And let me take a DL here. According to Ampere's law, what is B net? B net into integral of DL should be equal to mu naught. What is the net current enclosed? Of course, the current I is flowing, but what is the net current enclosed? Is I only. And what you are going to write? B net equal to mu naught I by 2 pi r. Will I agree this? What is the radius of the pipe? Is capital R. On the surface of the pipe, what should be the magnetic field? Will it be zero or non-zero? On the surface means here. How much it should be? Mu naught I by 2 pi capital R. Will I agree this? I'll write it on the surface. Keep this data in hand. So how that mu naught I by 2 pi R it has become? So let me break up here. So shall I say these two fields will contribute, no? B1 and B2. Together they contribute. When they both contribute, what happens? It becomes mu naught I by 2 pi R. Are able to get that logically? So the resultant field is become mu naught I by 2 pi R. How it has become mu naught I by 2 pi R? By adding up these two fields. By adding up these two fields. So what is the field B1 I should write? Half of this mu naught I by BP by 2. What about B2? It should also be BP by 2. I'll accordingly change symbols here. This we took B1, B1, B2, B1, B2.
Sir, in the bottom, the B1 should be towards left, no, sir?
Here.
Yes, sir, in the bottom.
Yeah. Okay, I think, yeah, fine. Now, what is B1, B2? B1 plus B2 is what BP, no? On the surface. What is the field at this particular point? Is it only due to this sheet 1? Is it only due to sheet 1 here or due to both? Due to both, no? So what is B1 plus B2? At point P, what should be the field? Should be due to B1 and B2. So therefore, B1 equal to B2. But sir, this is a ring So it is also like a non, like a large current carrying sheet because there is no beginning, no end. So it will be like a non-conducting sheet only. So on the surface, so therefore now what is value of B1? B2 should be equal to BP by 2. Now let's assume that, shall I assume that one? This surface now present in the field produced by the point P will experience force due to the field produced by the second sheet or the second element. The first element, and there's a second element you assume exactly symmetric to that. So shall we make out like this? The field produced by the second element, due to that what when the current flowing in the first element will experience a force similar to capacitor charged plates. The charge present on negative plate will experience force due to field produced by the positive plate. The similar idea is what you have to bring. The current flowing in the first element 1 will experience a force due to field produced by the second element. And that force I'll calculate. That force per unit area will become magnetic pressure. So how to calculate that value? That value of B1, B2 is what I brought it here. Okay, I agree this one. So now let's get into the real part of the problem. DF, the force. How I should bring it now? DF is equal to DF is equal to. So shall I write B2 B2, the field produced by that B2 into how much of current is flowing in the element 1? Di. What is the length of that? Dl. So what is this DF? Force experienced by the strip 1. Here you can see that by strip. I'll write in detail. If you are able to write this, rest all very easy. Huh? Force experienced by strip 1 due to field produced by strip 2. So directly write strip 1, strip 2. Now what you can write it? So this df equal to B2, what you can write? B2 as BP by 2 di into dl. Further, what is di? We should write it. What is the current per unit I by 2 pi r? Because total current is I, no, on the surface of the pipe. So lambda will be how much? I by 2 pi r. This is lambda, not any other symbol, lambda. What we assumed it. So now di I can write it now. BP 1 by 2. BP is mu naught I by 2 pi r. Di is what? Lambda into dx into this is dl. So further 1 by 2 mu naught I 2 pi r. What is lambda? I by 2 pi r. Dx dl. What you can write? Dx dl. Dx into dl, area of the strip. Books they're given directly formula, but you'll not understand. That's why I just picked up the basic method. So the df by dx into dl, this should be equal to mu naught I square 4 pi 8 pi square r square. This is force per unit area. So force per unit area is what you can call pressure, magnetic pressure. You write PB like this symbol. There's a magnetic pressure. How do this force will act? What about direction? This is something of all very important is like I brought Ampere circuit law. Then what happened? We are just calculating near the surface. We know as I move away, what happened to field. I think there are many things are there. As I move away, according to this, the field will increase. On the surface, I'm calculating. That is equal to capital R. And I'm treating like this is like a large conducting sheets. This because there's no beginning and end. So then take superposition similar to that one. So how to calculate that B1, B2? Again, we have a method here. Already I brought it, no? Mu naught I by 2 pi r. Now, what about force? How that force will be? So again, you have to take the Ampere's law. So how the field will be? You look at this one. B2, how B2 will be? B2 will be like this. B bar, the current. So force is it radially inward or outward? If a current I flows through a structure, I think I can give only a plain diagram. 3D diagram not possible. Current is here. Anybody? How the force outward or radially inward? There are only radially inward or radially outward. B bar is tangential, no? Put B bar, put finger, pointing finger, that one, and middle finger, put it. So if you when you twist your arm, no, that one, so it will come radially here. So this will be DF like this. So everywhere the force will be. So what will happen to this pipe now? We'll try to contract. We'll experience a contraction. So how the questions are asked for you is rather than magnetic pressure. No, if I say magnetic pressure, people will write this answer. So therefore, if a current if a current I flows through a pipe, like a copper pipe, then the pipe will contract, the pipe will expand, the will contract. We'll try to contract, no? And who will balance this? Who will balance this? So you you have to bring a tension. How the tensions will act in this direction. So I'll ask you find the tension the this particular pipe. No, so all application problems will do come for you. There's a basic idea now. We must know what is the thing. So when you get a problem like this, no, you can't write the formula energy density b square by 2 mu naught. Calculate b square, you get the same answer. What is b equal to? Mu naught I by 2 pi r. Substitute that. You see, you will end up answer very easily, no? 1 by 2 mu naught I by. Then how much will get it? Mu naught I square 8 pi square r square. It's over. A pipe will contract or expand. Who will answer that? So you can't do preparation for advance of these kind of. What is the unit for this? Energy density, joule per cubic meter. Energy density, no, joule per cubic meter. Pressure also what happened? We can convert that. Or Newton per meter square. No, both are same. So therefore, this magnetic energy density also what I can call it as magnetic pressure. Both are same. Or magnetic pressure. So we can't answer, we can calculate how much magnetic pressure, but you can't answer will it contract or expand. So you must have a basic idea. You should have worked out. I'll ask you to calculate tension. I don't think so. This will help you much here. You must have initial that force analysis here. That's why I just brought here. So the tension on this element, it should act there. On this element, it is like this. On this element, it is like this. So the dF is deforming force. This tension will be like a restoring force. So calculate the tension per unit length. All such questions can be asked. You have to be very careful. Okay, tomorrow I think we have a class. Okay, tomorrow I'll continue. A few more are there. Okay, thank you, all of you.